Hello, so this video is regarding assignment 3. So this is a group assignment and I am member of group 4. So our group contains two members, myself Navjot and Mehakpreet Singh. So this assignment is based upon circular data structure, array data structures. So starting with the introduction of circular arrays, so they are basically the array data structure that stores its elements in circular manner where the last position connects back to the first. This structure allow efficient operations like adding, deleting element from the both end and facilitate a looping behavior. So basically, it's a circular array as we can see in the image, which has zeroth index, first, second, third, and fourth. So here is queue back and here is queue front. So again, it will just connect with each other. So it will continue a loop, circular loop, where you can start iterating and find the required values. So comparing circular arrays with linear, so they have different structure and functionality. As linear stores elements sequentially, where with the clear start and end, making indexing for straightforward, whereas loop on the other hand allows contiguous transversal. So this loop features enable circular array to optimize space using index management, making them ideal for application like circular queues and ring buffer, which require respective or cyclic operations. Linear array, by contrast, are better suited for static scenarios without need such cyclic behavior. So talking about circular arrays, so it basically plays a main role in memory efficiency as talked in advantages. So it's enhanced memory efficiency and it has constant time complexity. So it basically access the element in constant time. Along with that, it has simple implementation. So while we use circular array when we are implementing circular data structures, so it make code more clean and maintainable in case of circular data structures. Now talking about disadvantages, so the first and foremost disadvantage about circular arrays are they have predefined fixed size, so we cannot change the size when afterwards. So another talking about the next disadvantage, that is overhead resizing. So when we try to resize the array, it may impact the performance of your program. So now talking about real world examples of circular arrays. First is multimedia buffer. So like circular array are used in audio and video streaming, which manage buffer efficiently, allow the user to continue for continuous data flow without need of shifting element, which ensures smooth playbacks while playing music videos or audios. The next one is round robin scheduling. So in so this thing is used in most of the operating system as it help to implement round robin scheduling and cycling through fixed process order, ensuring order in and fair CPU time allocation. The last one is data structure. So we all know like implementing circular arrays help a lot in implementing queues, which is used in printing, spooling, and in other data structures as well. So now Mehakpreet will continue from here, explaining the code part.
Hi there, this is Merkut Singh, and now I am going to explain you about the implementation of circular array in C. So circular array are typically implemented using a fixed size array. So you can't change the size of an array after you have implemented it. And it contain two pointers, front and rear. But in the implementation, I will take two more integers, size and the capacity. And for circular array, the main thing is that we use modular arithmetic operator to decide which value will go to which index. So key operations are insertion, deletion, transversal, accessing elements. To insert an element, the rear pointer is incremented by one, rear plus one more mod size, and for deletion, the formula is same. For transfers, we basically take a loop. We basically take a for loop and iterate through all the circular array. And by assessing element, we can simply assess element by using formula index plus front modulus size. Now I'm going to explain you this through a code. So as you can see, this is a code for circular array. And I have created a type def of struct, which is called q. In it, I have a integer pointer of array for basically constructing an array. After that, I have front and rear integer will be front and integer will take the will show us point to the front in an index of an array. Rear will be pointing to the last index of an array. And we have size index. Sorry. Now we have size integer to tell us the size of our array, and capacity is how much in values it can store. Now in now let's move to initialize q function. In the initialize q function, takes an integer which is basically a capacity, as shown in upper. Here will be initialize a q struct pointer, and our call a function with the value of 5. So it basically says that our array will be of 5 capacity. It can hold 5 values. It will first construct a cube using a malloc. If it fails, then it will show us the message and it will exit. After we will initialize a pointer name array, which is point to the array using a malloc. If the it is not constructed, then it will free the queue and exit the program. And afterward, we initialize the value of front rear size to 0 and capacity to the capacity of an array. Here you can see, which is basically a parameter, and it will return q. Now next function is Boolean function. It basically does is that it returns 0 if the it returns true if the queue is empty, and if, it returns false if it is not. After we have enqueue, which is basically a insertion of an element in a circular array. And if it will check first if the queue is empty or not. If the queue size is equal to queue's capacity, then this means queue is full and can't be enqueued, and it will return after that. But if it is not, then then queue's array then we put here index will be same as a value. Afterwards, the rear will be incremented by 1, and the size will also be incremented by 1. After next is dequeue. So it will check if the queue is empty. If it is, then it will show a message queue is empty and we can't do TQ and return -1. If not, it will return the value, and it will decrease its size by 1. After peak function is used for the peak, or we can say the front to show the front value of a in a queue. After that, we have a display queue, which basically do is that it displays all the content of a circular array. And in this, firstly it check if queue is empty, and it will print queue is empty and exit the program function. If it is not, then it will print the queue elements, and we print the queue elements using the for loop. In the for loop, we have taken a integer I for started with 0, and we have written here that the I is less than queue size. So let's suppose its size will 5, so it will only move 5 times, and afterward it will put the value to the index. Now you can hear the see that we are using the modular operator here. So it is basically used in a circular array, and we're not using the normal one. And afterwards, we will print the value of that element in the index. So now let's do some practical. Now here I have created a initialize a queue, or you can say a linked list of 5 elements. Sorry, not linked list, circular array of 5 elements. So basically means the capacity of an circular array is 5. After I have NQ1, NQ2, NQ3, and NQ4. You can see only 4 elements. So now let's see. And I also use the function display queue to show all the values. Now run it. As you can see, the elements 1, 2, 3, and 4 are completely in the circular array. Now let's try incube one more. 5. As you can see, it is also implemented in the circular array. Now let's try adding sixth one. As we have only five element capacity, and we are adding six. Let's see what it will show. There, can you see it? The queue is full. Count and queue 6. It shows a message, and we currently have elements 1 to 5 here. Let's remove this one. Now, if I want to dequeue, or you can say remove the element from circular array, I can simply dequeue it. Let's dequeue 3. Let's dequeue 1. So I will control X, move it here. Now let's see. Wow, as you can, the first one is dequeued, and the queue element remaining are 2, 3, 4, and 5. Now, if I want to add now sixth one, I can simply do it here. Now you can see we have value 5, 5 at index 4. So now the sixth value will be moved to index 0, as we have removed 1 from index 0. Let's see. Wow, it's been added. As you can see it's moved to the index 0. And now our front become index 1 and rear become index 0. And here I have freed all the dynamic values. I have freed the array, which is basically created by a dynamic allocation of memory. So this is the presentation of my implementation of a circular array in C.
Now I am Navjot again here to explain the time complexity and case study of this case study about the circular array. So the time complexity, if we compare with circular arrays and the linear arrays, so if we are inserting an element at the end, so it's O of 1 for the both like constant time. If we are inserting at the beginning, so it is O of 1 for the circular but O of n for the linear arrays. And then for the deleting an element at the end, it is same O of 1 for both of them because we are not shifting any elements and stuff. Again, for the deletion from the beginning, it's O of 1 for the circular, but it is O of n for the linear array. And for last transversal, it's O of n because we are iterating through whole list of elements in array. So it's O of n. So now I will start discussing about the case study. So for case study, the problem we are taking is CPU scheduling. So talking about CPU scheduling, so in modern operating systems, CPU scheduling is very crucial because of optimizing resource utilization and ensuring fair process execution. So the challenge lies between managing multiple processes in the way that it requires minimum waiting time and maximum CPU utilization while avoiding the starvation. So the traditional scheduling algorithms like first come first serve and shortest job next often struggle with fairness and efficiency, especially in multi-programming environments. But round-robin scheduling is widely used approach which require a robust mechanism that cycle through process efficiently. And this is where circular array came in play when we are talking about CPU scheduling. So why circular arrays? Like we can use anything, but why we are using circular arrays? So there are three main things. What is first one is efficient process cycling. So when we are using circular arrays, so it allows seamless transversal from the first to the back to the last, first to the last and back to the first process, eliminating need for additional logics to reset pointers, which could be used when we are using linear arrays. So second one is constant time operations. As we know, insertion and deletion of processes in circular arrays are performed at constant time, which will ensure minimal overhead during scheduling. And the last one, which is like very important for embedded system, which is memory optimization. So as we know, circular arrays utilize memory efficiently by reducing space. That's why it's crucial when we have limited resources like CPU powers and storage, and that's why it's best for embedded system, as we know they contain less memory. So for example, in round robin scheduling, each schedule is assigned to a fixed time slice, and the circular ensure that the process is revisited in the cycle ordered while maintaining the fairness and reducing the risk of starvation. So if we compare the linear array and the circular array and linked list while for this condition, which is CPU scheduling. So like the linear arrays are simple to implement, but they require additional logics. We have to reset pointers, and which leads to additional computational overhead and memory usage as well. Along with that, if we are talking about linked list, all the linked list like we can offer dynamic resizing for them, but when they acquire high memory, which is not good for embedded system, and it also slow the transversal time because allocation is increasing, it will decrease the efficiency of your CPU. So that's why circular arrays strike a balance, providing constant time operation and memory efficiency, which make it ideal choice for round robin scheduling rather than linear arrays and linked list. As most of the studies also shown that the using circular array for CPU scheduling achieve lower average waiting time and higher throughput compared to those using alternative data structure like linear arrays and linked list. So in conclusion, we will just talk that circular arrays are very crucial for transversal insertion and deletion, like and some real world example like multimedia sports, CPU scheduling, games mechanism like multiple there are multiple player games. It is best to use there for and every cyclic operations which needs a data structure. It is circular arrays because they are easy to implement. They use constant time complexity. They use less memory and allocate maintain proper spaces, and that's why it's most used commonly used in CPU scheduling and embedded systems. So if we are talking about its future enhancement and what future work it could be, so basically I think if in future they explore like how to dynamically resize the circular array without in like increasing the demand of thing, and that it dynamically allocate memory without increasing overhead and stuff. So it will explore we will explore a hybrid approach that will both leverage a circular array of efficiency and adaptability of linked structures. Like in linked list we can and like change the allocation dynamically, which will enhance the computational power very much, and it will also explore new areas and enhance algorithm and optimization of hardware by using circular arrays. Along with it, if we are able to make this thing, so we will also able to solve like very complex computational problems as well. So this is my conclusion about all of them. So lastly, we have references. They are different websites, books, and some of them are resources that are taken from internet. Thank you very much. This is end of my assignment. Thank you very much.